After learning this, you are going to find it very easy to go through all those complex and graph algorithms that we. What's good, you guys? So in this tutorial, we will be learning graph terminology, or you can say all the basics of graph, like what are its components called, and all different kinds of graph, so that after learning this, you are going to find it very easy to go through all those complex and graph algorithms that we implement using the graph data structure, right? So make sure you watch the video, and let's get into it. And wait, if you are new to this channel is all about programming and life related content, so make sure you subscribe. And now let's get into the video. Okay guys, now let's see what a graph data structure is. Okay, so a graph consists of nodes that are connected uh, with edges, right? So here, what are nodes? So these circles that you see, those are nodes. Okay, here there is a node, these all are nodes, right? And nodes are just referred to as vertices, mainly because if we see a rectangle, okay, so what are its vertices? The points, right? The ending point, the points which are connected by some edges. So here is also the same case, kind of. So these all nodes are also called vertices. Okay, but your nodes are you just will just refer to these as nodes, right? So you may understand nodes as some like a basic unit of a data structure that holds some data, right? So if you want to know more about nodes, I had made another video on trees that you can just go to, and I will leave the link in the description below, or it will pop up in the card above now. Okay, so that's it. Just these are the nodes. These circles are the nodes, and they are connected by edges. These lines you see, these lines, okay, these lines are called edges, right? The edges are the lines or arcs that connect any two nodes in the graph, right? They may connect, they also may not connect, but the lines that connect any two nodes, right, we call them as edges. So every line here you see here are edges, and you may see that some lines have arrows and some are not, and that is all. You don't have to worry about that now. We will discuss that further ahead in the video, right? So just that's the base, this is the basic. Now just you need to know that a graph consists of some nodes, and the nodes are connected by some edges, like the lines. Okay, so now let's jump on to the next thing, right? Okay, now let's see what is a path and what is a cycle, right? So a path leads from one node to another through edges. So if we consider this node 0 and we consider this node 2, so what is the path between those? The the path will be 0 to 1 to 2, or there are other paths too, from 0 to 4 to 3 to 2. So these all are paths because they are connected through edges. We can go from 0 to 2 through this path, or from this path. All right, so this is one path. Okay, this is, and this is another path. All right, so the path from one node to another node through the edges is just a path, right? So it's very simple. All right, so now let's see what is a cycle. So a cycle is a path where the first and the last nodes are the same. For example, if we consider this node, all right, if we consider this node 1, and also we go from 1 to 4, 4 to 3, and the from 3 to 1. So what does this make it? This is a cycle, right? Because the first node from which we start, we come to the that node again by passing through some edges, right? So this makes it a cycle because it's closed. But if we take from 1 to 4, that's not a cycle. If we take from here, that's not a cycle because it's not closed. Okay, so understand that if you're starting from the from one node, for example 3, and we are able to again come back to that node by going through some edges, we are forming a cycle. Okay, if we consider 3, we can go from here to here, then we can go from here to here, and you can go from here to here, then we come back again. So we are forming a cycle. It's closed, you can see it is closed, right? So that's what a cycle is. Okay, So now we have understood what a cycle and what a path is, right? So now let's jump on to the next thing. Okay guys, so now let's see what a connected graph is and what is a disconnected graph, right? So if you see the definition, a graph is said to be connected if there is a path between every pair of vertex. From every vertex to any other vertex there should be some path to traverse. So what that means is that uh, if you see the diagram below, see the these two graphs below, all right? So this is one graph, all right? This is one graph and this is another graph. Okay, so this is a connected graph and this is a disconnected graph. So let's see why. Okay, so our what is a connected graph? You can simply understand that if we are in the graph, we are able to traverse from any node to any other node. Just we are able to traverse by through any path. Okay, through any path we just need that from any node we choose. For example, if we choose this one and if we choose this one, we should be able to traverse it from any path. Okay, we just need an existing path. That means that the graph is connected. This means that this may not be connected to this one directly, but we can go through go to this node from by traversing any path that we have. Okay, that's called an connected graph. For example, if we take this one and this node, these two may not be directly connected, but they are connected through this path, right? So this is a connected graph. Okay, but if you see this disconnected graph, we have components inside a disconnected graph because they are not connected, so they are split into different different components of a graph. Okay, so this is, if we take this graph, we can traverse from this node to this node by any means because they are not connected. For example, if also there must have been a node here, this graph may have been a connected graph because we could have traversed it through this path, but not, it's not possible. So that's why this is a disconnected graph. So it's split into three components right here. Okay, so that's a disconnected graph, but a connected graph is always a single component where we can traverse from any node to any node through any path. Okay, so that's that. I hope you understood this. It's pretty simple, right? Okay, so now let's jump on to the next one. Okay, now let's see what is a weighted graph. Okay, so let's read the definition first. A weighted graph is a graph in which each branch is given a numerical weight. Okay, so we can see this example, right? See, every edge that we have a numerical weight that has been assigned to it. Okay, so what most of the peoples at first glance, they just misinterpret these weights as the length of the edges, but that's not the case. Okay, so don't have this misconception. It's just a number that is assigned to every every edges for some calculations. Also, just a quick thing to learn that maybe I've missed out in the previous I was explaining you the previous things. It's just a basic thing. Okay, so we have two kinds of graph mainly. If we have an undirected kind of graph and directed kind of graph. So if in a graph we find we have arrows, like we know from where this node we have to go to the fourth node, and from one node we have to go to third node. So that is called a directed graph. And if there is no arrows, like we saw in many other graphs, like for example this graph, we have no arrows, this is an undirected graph. Okay, so that's what I just wanted to tell you. Okay, now let's see what are the degrees of a node. All right, so if we leave the example here, we'll know that a degree of a node is its number of neighboring vertices. Very simple. All right, so let's see what it's trying to tell us. For example, if we consider this graph, don't consider the arrows now, because when you are just considering degree, we just need to focus on the neighboring vertices. All right, so if we try to find the degree of the uh, the 1th node of this graph, so how many neighboring vertices does it have? So it has 3 was one of its negative vertices of 1, right? 4 and 2, so its degree will be 3. If we consider 4 here, okay, just let me clear these things. So if we consider 4 here now, how many what does what is what would be its degree? So it has neighbors like 1, 2, 3, 4, 5, 6, like direct neighbors. To, and by neighbor I mean to which it is directly connected by a edge. Okay, to which it directly connected by edge. So it has 1, 2, 3, 4, 5, 6 neighbors, right? All right, so that's how it's simple. Just find out, if you want to know the how many degrees that 5 have, just count how many nodes it is directly connected by a edge. Okay, so here it is connected to 7 and 2, so it has 2 nodes. Okay, so that's that. Now if we see the next thing called in degree and out degree. So what is the in degree and what is out degree? Now we have to consider a directed, to understand what is an in degree and what is an out degree, we have to consider a directed graph. So the now let's just these are very easy definitions, you will just know right away what is it. So the number of edges directed away from a graph or node are called out degree. See, just remember, away is out degree, and the number of edges directed towards a graph or node are called in degree. Towards is in degree and away from is out degree. So if we see that example again, so now we will consider these arrows, right? So if we consider degrees, we don't need to consider the arrows, we just need the direct edges to which it's connected to. But if we need to know the in degree and the out degree, we need to know the direction of the arrows. So if we consider in degree, right, so what would be the in degree of 4? Okay, what would be the in degree of 4? Let's see. So 4, what we saw in the definition was the edges which are directed towards it are its in degree, and the edges which are directed outwards are its out degree. So if we also maintain a counter for the out degree of 4, all right, so first we'll count the in degree of 4. So here we have the number of edges directed inwards to 4. So what are those? This is one edge, this is one edge. See, all these edges are inward, towards, coming towards 4. All right, so it has 3 in degrees. Okay, it's simple, right? It's 3 index and 3 in degree, and out degree are the number of edges that are like away from the current node. So what are those? Here this one is going outside, one, this one is going outside, another one, and this one is going outside, another one. All right, so we have also 3 out degrees. Now let's take another example, I think. Okay, let's just see another example. Okay, so if we have let's consider 2. All right, let's consider 2. What would be its in degree? What would be the in degree of 2? What would be the out degree of 2? You try to tell. Okay, okay, I think you know that. Okay, so in degree will be the number of edges coming in. Here we have one edge coming in and nothing are going in, all are just going out. This one is going out, this one is going out, so 2 are going out and 1 is coming in. So we have in degree 1 and out degree would be 2. Simple, right? Yeah, it's pretty simple. Okay, now let's see what other exciting things we have here in the graph. Okay, let's now see what is a regular graph. So let's read the definition first. A graph is a regular graph if the degree of the node is constant. Okay, so the d that we read above, that is the number of neighboring nodes, direct neighboring nodes that it's connected through by a edge are called degrees, right? So if the degrees of every node in a graph is constant, so that's a regular graph. So let's consider this graph. Okay, so if we take this node, okay, what is the degree of this node? What is the degree of this node? This is one edge, this is another edge, it is connected to here directly. Okay, directly. So we have 4, right? 4. If we consider now 2, okay, if we consider the degree of 2 now, how many nodes is it connected to directly, right? Here is one connection, here is another connection, here is another connection, here is another connection, so it's also connected by 4. So if you'll see like that to all these nodes, right? You will always find the answer 4. So that means that this is a regular graph because all the degrees of every node in this graph is same. So we call this graph a 4 regular graph. Okay, so like guys, now let's see what a complete graph is. So a complete graph is a simple undirected graph, okay, in which every pair of distinct vertices is connected by a unique edge. So you can just simply understand a complete graph by just understanding that if in a graph uh, every node is connected to all the other nodes, right? To like every node is connected to all the other nodes by a simple a unique edge, okay, a unique edge. Like for this example, taking this node as an example, you're connected to all these nodes by just a simple edge, okay, just a unique edge, nothing else. So it is a complete graph. Like if every why is it is called complete, because every node is connected to all the other nodes by an edge, so that makes it a complete graph. Okay, there can be no more edges, nothing else, because everyone is connected to everyone, everyone is happy, right? So okay, now let's just see some important from some important facts on based on the complete graph. So if we take the number of vertices to be n, so in if we consider this case, we have n to be how much, 5, I guess, okay, because n is 5 because the number of nodes is 5, that is vertices. So it tells that the degree of each node is n minus 1. Obviously, why? Because if we consider this node, and we know degree is what, the number of nodes, it is directly the number of neighboring nodes that it is directly connected to through with edges, and we know in a complete graph it is like connected to every edge but itself. So that makes the number of degrees of this node to be 4, right? That is n minus 1, that is 5 minus 1, because it's connected to all the other 4 vertices, because it's a complete graph. So now another thing is that the number of edges is equal to n into n minus 1 by 2. So we know what the edges are, right? So n is equal to 5, and we know the edges are the lines. So let's see, is it right? So n into n minus 1, so edges should be how much? 5 into 5 minus 1, 20 by 2 would be 10. Let's count how many edges does it have. Here is 1, 2, okay, let's just make it simple. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's it guys. This was the video. I hope you learned a lot about the graph data structure, and you can now dive into all those awesome like algorithms, or like Flood Warshall, Bellman Ford algorithms, and you can just understand it. All right, so this was just a basic video on what types of graph, what is a graph data structure, what is types, and hope you understood something. And thanks for watching the video, and I'll see you